All right, so it seems that most of you are here already. So do you guys have a question so far before we'll continue our discussion?
Wala naman po, sir.
Sir, I want to ask the empty row in between. Is it telling us that it's listed all the attributes down to the last one?
Pardon? This one?
Yeah, this one. For the table we have below, we have ID number, then we have the first row, then we have an empty row, then we have the third row. I mean the two dot is it telling us it listed all the elements down to the last one, or it
Yes,
actually
yes, yes.
listed it?
So
Okay,
basically we have 10 tuples. No, no,
okay,
sorry. We have 5 tuples only. Okay. So
five. Yeah,
from here to here, and then followed by this table, wherein the format that this one is following, the PID, is the format of your ID number. So as you can see right
okay,
here, 22012 and then 180, which the same with your ID number. Okay. So this one is now interchange or change to this format. Did I answer your question, Mr. Folaweo?
yes, sir.
Okay. So since there's not enough space, so we've only shown here the dot dot. Okay, meaning we've shown up to the second, up to the last tuple. So as you guys may know already, we have a total of 66 slides for this module. So I'm afraid we won't be able to finish everything for this module number 5. So I don't know. So whatever the topics that will be finished up to the part 3 or part 4, so that depends. Then that's it. Then we'll just continue the rest next meeting. All right. So let's have an example or an exercise rather, not an example. So consider exercise for the following tables. So we have 4 tables. We have employee, we have buyer, department, and then supplier. Then of course they have their own uh, attributes and tuples. All right. So here are the questions. Number 1, find the names of all employees. So do not include any managers. So anyone who wants to answer number 1, find the names of all employees. Do not include any managers. So just the name of the employee. All right. So I will answer number 1. Project. So once you see this one, okay, do not include any managers. So meaning we're now excluding some of the attributes. So if we are excluding some of the managers, then you have to use the project operator, okay, instead of the select operator. Okay, so from here, just project the table employee since that is the question, and then the attribute name only. Right, so in that case, you're now showing uh, the column of this table, which is name only. Okay. And yeah, forgot. So do not include any managers. So maybe you can include here the ID number and the name only, since the only limitation is you should not include manager, or exception is manager. Right? Anyway, to be more exact, I'll only display the name. Okay, so that is the answer for number 1. How about number 2? Find the names of all managers. Filter only names of managers. Okay, so how will we answer that one?
Project
So
employee
we have here
managers.
the attributes so that we'll not be going back to here anymore. So we have the attributes of employee, ID, and then name, and then manager. Okay, so anyone who wants to answer number 2?
Project. Maybe. department manager. Can you start also?
Employee. And then?
Can we use department manager also?
Department
Like
manager.
project
Find the
just
names
department.
of all managers.
Yeah. Since we
Filter
have it on
only
that.
names of managers. All right, so let's see. So you can use department table or use department, table employee. Okay. So as you can see, we have a lot of managers here, but in total, they are just the same. Okay. Since the duplicated names of the manager will be eliminated. Okay. Going back to here, where is that one? Projection. So it's here. It says here for the projection operator, duplicates will be eliminated. Okay. So you can answer the employee or the department. Okay. So either of those two. So you can have that, or you can have this one. Department. And then manager. There you go. All right. So those are possible answers for number 2. How about number 3? Anyone? Find all part numbers. Filter only part numbers. So if you're going to take a look at this one, we have 2 part numbers. So part number for buyer and then part number for supplier. But in here, you have to take a look on the table now. Okay. Since this one is much more complete, I guess. 335 to a yeah, this one is much more complete than this one, since this one has the 772 table or element, but in here we don't have that one. Okay. So the question here is find all the part numbers. So we have to indicate everything. Or yeah, that's the only possible answer. So there's no or, sorry. So in here, project from what table name?
Supplier.
Supplier. And
Part number.
part number. So as simple as that, right? So we have a continuation. So 4, 5, 6. So 4, find all names of buyers. So filter only names only. Anyone who wants to answer number 4?
Project buyer. Name.
Project buyer.
Name.
Name. Right. How about number 5? Find the names of all employees who are managed by Bote.
Project employee.
Employee.
Name.
Name. And then?
And
Pardon?
Wait. We have to, can we use, let's say?
Yes. So you got it. So we have to use project and select at the same time. Okay, so let me give you guys the format. So after this project, we have the select, followed by the table name. So what is the name of the table?
Employee.
Followed by the condition.
Manager.
Equals Bote.
Equals to Bote. Okay. So Mr. Agustin already answered that one for you, Mr. Polabewo. And then what is the last one? So in here, we will only project the name of that
Name employee.
So as you can start here, we have to initiate this one first. We're going to look for the tuples wherein manager is equal to bote. Then once we're done with that, then we will only display the name of under the manager is equal to bote. Since the requirement here, find the names of all employees who are managed by bote. Okay. So the only one that will be project is name under manager bote. All right. How about number 6? Find the part number being managed by Pablo. Filter only manager and part number. So let's go back to the table. So find the, what is that? Find the part number being managed by Pablo. So part number that is being managed by Pablo. So from here, we have the manager wherein it has a department of 66. And then if you're going to take a look at this one, 66 department is part number 42. So the question here is we have to project the manager and part number only. Okay. So actually it is coming from 2 tables. So what will we do? Anyone who has an idea? All right, so I guess none. So the first thing that you need to do when it's asking you to project 2 attributes that is coming from 2 tables, so there's a big chance that you can combine those 2 tables to come up with 1 table only, okay? Because we cannot select and project 2 tables at the same time. So we can only select and project 1 table, okay? So from here, we have to join the department and supplier first. So where is that? No, we don't have the format for join. Anyway, so we have this format, so X, and then the name of the first table. We have here department, and the link attributes wherein they are common with each other. So as you can see, they are common in terms of department. So department is equal to department, followed by the name of the second table, supplier. Supplier. All right. So once you're done in combining those two, so of course, it will give you a new name. So let's just say that the new name of that table is department supplier, right? So from there, you could use now the project, followed by the select, and then the name of that table. So I'll just assume that the name of that new table is a combination of those two. So department supplier, and followed by the condition. So what is the condition? So find the part number being managed by Pablo. So part number is equal to Pablo, or manager is equal to Pablo. Yeah. Manager is equal to Pablo. And yeah, that's it. And for the last one, we have to project to the part number and the managers. Is this correct? Filter only manager and part number. Yeah. So there you go. So here's the answer for the number 6. So first we combine them, and then from the combined tables, then we can now do this condition. So manager is equal to Pablo. Then once you're done in looking for that tuples, then we will only display the part number under manager Pablo, and then the name of that manager. Right? Did you guys understand number 6?
Yes.
Is there anyone who's confused? All right, so guess none. So it's maybe 100% yes that you're confused, or 100% no that you're not confused. Anyway, so if ever that you have a question or clarification, so feel free to message me anytime to my Canvas account or my Facebook account. All right. So if you guys do not have a question regarding with this exercise, then you may now start and answering seat break number 1. Okay, so we have 5 questions that is coming from this table. So basically the same table, but just a different question. All right, so you can answer this one using Microsoft Word and or handwritten. Okay, so if you're going to do this one handwritten, please write legibly. Right. So any questions so far regarding with your seat break number 1? So do not analyze it for now, okay? Since you will not last long for this slide. So just ask me later on, okay? Once you're now answering or starting to answer this sit work number 1, right? So basically the same concept, and then this is work people. All right. So that's it for your sit break number 1. So let's now move on to the next one, since again we're limited when it comes to time. So the next one here is union operator. So this one is very similar with the topics that we have discussed before. When say union, we will basically combine two tables, okay, but not side by side. So in here we will combine them, okay, uh, vertically or by column or by attributes. So you can only combine or you can only use the union operator if they have the same attributes. Okay, so they must have the same attributes. If they don't have the same attributes, then you won't be able to uh, union them. Okay, so as against right here, we have this syntax R1 union R2. So R1 is representing the first table, and then R2 is representing the second table. So for example, we have teach M, this is your first table, and then union non teach M, this is the second table. So of course, first table first, followed by the second table, right? And then at the same time, it has this function wherein it will remove the duplicates. So if ever we have duplicates from this second table to this first table, then it will be removed by this operator. Right? So did you guys get this one so far for union? Hello? Are you guys still there?
Yes, sir.
Yes, sir.
All right. So did you guys get this one or no?
Gets naman po, sir.
Yes, sir.
You guys sure? Seems that you guys are not listening. Anyway, so again, if you have a question, so feel free to ask me anytime. So that's it for union operator. Okay, so they will be combined by attributes. Then we have here intersection operator. So same concept, they must have the same attributes. And then as you can see, when you see intersection, you will only get, okay, or we are only getting the common tuples between those two tables. So let's say we have R1 intersection R2, so teach M intersection non-teach M. So of course, it will only get or it will only display the common tuples or the same elements of tuples. So since right here, we only have 2, which is this Aquino and then Clara. Okay, 20,000 and then 10,000 ID number. Right, and then the rest will be removed. Right, so understand so far?
Yes, sir. Naget naman po.
Yes, sir.
Next one is difference operator. So in difference operator, arrangement does matter in here. Okay. So you could have R1 minus R2 or R2 minus R1. Okay. So whichever is the first element, first table, that is the one that will be retained. Okay. And of course, the same condition wherein they must have the same attributes before you can use this difference operator. So we have two examples here. So pitch M minus non-pitch M. So we will retain the first one and then we'll remove the ordered common tuples. Okay. So as you can write here, the commonalities is Aquino and Clara, or 10,000 and then 20,000 from the second table. So we have to remove those two on this table. Okay. So we will retain Acosta, Costa, and then Fontiveros. Just remove the common tuples. All right. And if we have this format where in non-teach M first versus minus teach M, okay, then we will retain the second table and then we'll remove the first table that is common with your, or the common that is top, that wherein the tuples from this table is common with this table. Okay, so as you can see, again, they have commons when it comes to Clara and Aquino. So we'll remove those two and then retain De La Cruz, Rizal, and then Bonifacio, which is now this one. All right. So did you guys understand this one so far?
Yes, sir.
Can you guys still follow? Or
Yes,
are you
sir.
guys confused now?
Yes, sir. Nagets naman po.
Gets naman. Okay. How about you, Mr. Polawewa?
Yes, sir. I understand.
Mr. Mendoza? Right, so I guess he's not here. Mr. Agustin?
Yes, sir. Yes po.
All right, Mr. Gangas? I think said something, but I wasn't able to hear it. Anyway, Mr. Miss Sekligan? Okay, narinig ka na. Okay daw. Miss Sekligan? Yes, was right. Okay. Miss Rona? All right, so I guess Miss Rona is not here. Mr. Tanikala?
Yes, sir.
Okay, Miss Tandok?
Yes, sir.
Okay, Mr. Estadilla?
Yes, sir.
Miss Ginoran?
Gets po.
Okay, Mr. Paran?
Gets naman po, sir.
And then Mr. Vicente.
Yes, sir.
All right, so I think you speak, but I wasn't able to hear it. Anyway, so actually, I'm just checking if you guys are really there or no, because you know, a lot of my students, or most of my students, especially if it's a big class, so like 30, so 10 of them are not really responding, meaning they are not around. So they just joined the Zoom meeting and then did something else. Anyway, so it's a good thing that you guys are here. So the next one here is functions. So basically when I say functions, we have this pre-image and then this image. Okay, so it is composed of two different columns. So the pre-image is the before, and then the image is the new value of that pre-image now. So when we say pre-image, we have this function. Okay, that is why we call it function. Wherein in every function it has a corresponding formula. Wherein in here the formula for f of x, or for this function, is x squared. And then as you can see, the pre-image of 4 became 16. So you could see when we say function, it is forming a new value out of that function. Okay, so this is a special kind of relation wherein this pre-image is always related with your image. Okay, so it takes an element from a set and maps it to a unique element in another set. So this set is basically the same with the second set. So how did we arrive this with this second set? This one was derived from the first set with the use of a function. And that function that we're talking about is for a certain formula. So that depends on the formula, right? So as usual, we have this domain and then co-domain. Okay. All right. So let's move on to the example when it comes to functions. So we have the domain and then co-domain, or the x or the y. Okay. So we have Alice, Bob, Chris, Steve, and then Emma, wherein they are related with your codomain. So Alice is related with A, Bob is C, Chris is A, Dave is F, and then Emma is D. Okay. So as you can see, this one is a class grade function. Okay. So what is the grade of Alice? So there are some questions wherein something like this. What is the grade of Alice? So the grade of Alice is A. What is the grade of Chris? So the grade of Chris is A. And so on and so forth. And then we also have this question. What is the, or who has the grade of C? Okay. Or what is the pre-image of C? So as you can see, we have Bob. So another example, who is the pre-image of letter A? We are grade of A. So we have Chris and Alice. So, simple questions that can be answered by a function. So we have here a string length function wherein this is the pre-image and then the image. So this one has one string. This one has two string, 4, 2, and then 1. All right. So basically, this one is just a representation wherein in relation of string length, okay, or the count of strings. All right, so let's have basic terms. So whatever is the first one, or whatever is your domain, that is always your pre-image. Okay. Whatever is the second one, that is your image or range. Right? So as usual, your domain is X, and then your codomain is your Y. So just like what I have said a while ago, so the image of F Alice or function Alice is A. So meaning this one is, what is the grade of Alice? So A. And then pre-image of C is Bob, right here, means who got the C grade, which is Bob. All right, so those are like, kind of dumb questions or dumb analysis. Anyway, that is how we read a function, or that's how we interpret a function. All right, and here are the properties of a function. So a function f is always going or coming from x going to y. Okay, so it is a relation from x to y. Okay, so do not interchange those two. When we say x to y, x first followed by y. So y to x is a different function anymore. Okay, or function already. Okay, so we have two properties for us to be able to say that this one is a valid function. So first property here is the domain of f is x. So as always, it should be the domain, okay, or your pre-image, which is your x, and then it has one directed edge for every domain, meaning we cannot have two direction for your domains. Okay, so we'll be having an example later on, but for now, let's use this simple example. We have this function 1 wherein it has a relation of 1a, 2b, and then 3a from the coordinates 1, 2, 3, and then ab. So whichever is the first one, that is your domain, okay, or pre-image, which is 1, 2, 3, and then the second one here is AB, which is your codomain. So it says here, it is a valid function because the domain of F1 is 1, 2, 3, okay, so this is your X, and then it only has one directed edge of every pre-image. So meaning all of your domains has a partner, and then it only has one directed edge that is going to your pre-image. Okay. So later on, we'll discuss more what is this one directed edge only. All right. So this is now an example of not a valid function. So as you can see, we have this function 1a, 2a, 3b, and then these orders 1, 2, 3, 4, 1, 2, 3, 4, and then ABC, and then ABC right here. So this one here is not a valid function because the domain of f of 2 or function 2 is 1, 2, 3 only, which is again not equal to your x since your x is originally 1, 2, 3, 4. And as you can see right here, your 4 doesn't have a directed edge on the pre-image. So when we see a valid function, okay, all of your domains must have a partner, okay? But then again, it should be only one, okay? So one domain should have only one partner, and of course, it must have a partner, okay? That's what's one? This is terminology for that one. That is a requirement, or that is mandatory, okay? So if one of those is not met, then that one is not a function anymore, okay? Like for example, imagine that this one is the list of students. So number one has a grade of A, number two has a grade of B, number three has a grade of B. But number four doesn't have a grade, wherein in a class, it is not valid. So he or she should have a grade, whatever happens. Like if he's failing the class, then you should, or this one should have a grade of F, okay, or a grade of 72 or 73, okay. Wherein in this scenario, he doesn't have a grade, so this one is not valid anymore, okay, since that one is illegal, okay. So not actually illegal, but that is a requirement for us instructors to give you guys a grade no matter what happened, right? So did you guys get so far? And how did we come up with this example for not being a valid function?
Yes, sir.
How about the others?
Yes, sir.
Yes, sir.
Yes,
Right.
sir.
Okay, very good. Okay, so let's have more example. We have example number 3. We have 1A, 2B, 3C, and then 1B. So we have partnerings from 1 to 3 and then A, B, C for your Y. Okay, so this one again is not a valid function because if we're going to relate it again to a student and then to its grade, so it's like we're saying that this student number one, has a grade of letter A and B at the same time. Like he has a grade of 90 and then 85 at the same time. So he has two grades, wherein you don't have that one in real life. Okay, so this one is not a valid function anymore. Okay, so yeah, that is the reason why we must only have one directed edge coming from your pre-image, I mean image, then going to your coming from your pre-image and then going to your image. All right, so did you guys get this one, number 3?
Yes, sir.
Yes, sir.
Okay, so I'll only give you guys two requirements when it comes to a valid function. So all of your domains must have a partner, and those domains must only have one partner. Okay, so in image or codomain, so they can have as many partner as they can have, and yeah, they can have as many directed edge as they can have, but for the domain, they cannot, right? So once you're done in understanding about function, then you guys may know answer seat break number 2. So this one is super easy. You just need to tell whether it is a valid function or not. So just do this one using a Microsoft Word. So just put there 1, 2, 3, 4, and then upload it to Canvas. Okay. So 1, 2, 3, and then 4. All right. So are we clear so far for your seat break number 2?
Yes, sir.
Are you guys still there? Anyway, so let's
Sure.
move to
Yes,
the
sir.
next one. All right. So we have here the vertical test for a function. So this one is just a representation of a graph wherein if the vertical line cuts the graph of a relation in more than one point, then the relation does not represent a function. Okay. So you just imagine that those curves are coordinates that is formed from a relation. Okay. So you might have 5, 0, 7, 1, 8, 3, and so on and so forth. So those are coordinates. And it says here that if you're going to do a vertical test, let's say this vertical test here, and if it hits one or more than 1 point, then this function is not a valid function anymore. Okay, so as you can see, this one is not a valid function, and this one is a function. Okay, since wasn't able to hit one more point for this coordinates. All right. So yeah, how about this exercise? Okay, so let's see whether you guys have really understand the vertical test for a function. Is this a function? This graph?
Yes, sir.
Yes, sir.
Yes, sir.
How about this one?
Yes, sir.
Yes, sir.
How about this one?
No.
No. No,
No.
sir.
How about this one?
Yes, sir.
How about this one?
No, sir.
No.
How about this one?
No, sir.
No, sir.
How about this one?
Oh, sir.
No.
And this one? All right.
No,
No.
sir.
Okay. So just a quick discussion when it comes to vertical test or a function. All right. So writing a function. So we have this given relations. So A1, E2, E4, and so on and so forth. So the diagram can be written as function. So f of A is equal to 1, f of E is equal to 4, f of I is equal to 5, and then f of O is equal to 2. All right. So basically, we're just representing this sprite image to this image, wherein this function has a value of 1, etc., etc. All right. And then we have here algebra of